Homework 3.3, Polynomial Division, Factor Theorem, Remainder Theorem. Video 1. Homework due Wednesday, May 27th, 2020 at 11:59 p.m. The following video is associated with questions 1, 2, and 4 on homework 3.3. Okay, so we just got finished in the previous homework graphing polynomial functions. We found a variety of information prior to graphing. We found in behavior, we found y-intercepts, we found x-intercepts and multiplicities, and whether the graph crosses or touches the x-axis at those x-intercepts. But one of the problems with finding x-intercepts is that you have to solve something equal to 0. And the strategy that we used in the previous homework was factor it and set each factor equal to 0. But during those videos for the previous homework, I kind of hinted that sometimes that's not as easy as it seems, even if you know all the factoring techniques that were reviewed in Module 2 of this course. What happens if you get to a problem where you have to factor something and it won't factor using GCF or grouping, or it's not a trinomial, or it's not a difference of squares? The answer is we need a better factoring technique that will work all the time on problems that we can factor manually and ones that we can't. So like the quadratic formula, which always works, the factor is always drawn out, the factoring technique that we're going to develop always works, but is a drawn out procedure. So we're going to build up to this factoring technique. And the genesis behind it is we have something that was already multiplied, and we need to unmultiply it, we need to factor it. Well, one way to factor something is to divide it by something to get its other factor. For example, if I wanted to factor a number, like if I said, go factor the number 75. Write it as a multiplication problem, something times something. Well, if you know that 5 divides into it, then you could go to the side, figure out 75 divided by 5 is 15, and come up with another factor. So one trick to factoring polynomials is to divide it by something that you know will divide evenly. What you divide it by will give you one factor, and the quotient to the division problem will give you the other factor. Well, this raises a couple of problems. Number one, if we're factoring something and we don't know what to divide by, how do we know what to divide by? We'll cross that bridge eventually. And when we know what to divide, how do we divide it if we're doing polynomials? Well, the answer is polynomial division. See? Now there's two types of polynomial division. One always works, the other one works sometimes. But the other one that works sometimes is so smooth, it's worth having in your arsenal. So in this video, what we're going to do is review polynomial long division. And I do mean review, because if you've had an Algebra 1 class at any point in your life, and you probably have, then you've seen long division with polynomials before. But I'll still teach you how to do it from scratch, from step 1. So on the board I have a long division problem. We're going to divide x to the third power plus 2x squared minus 5x plus 2, and we're going to divide it by x minus 2. Now before we jump into this, a couple of comments. In a division problem, the part that you divide by is called the divisor, and the part that you're dividing into is called the dividend. I will be using those words quite a bit. The answer that we're going to get up top is called the quotient. And there may be a remainder. I don't know yet. I haven't done this problem yet. Now you may be wondering, why do I have this number long division problem over here? 1,252 divided by 12. Because I'm going to use it to illustrate how to do polynomial long division. The trick to doing polynomial long division is to ask yourself, what would I do if I were just doing a number long division problem? So for this first example, we're going to bounce back and forth between the number problem and the polynomial problem. And every time we do a move over here, we're going to try to replicate it over here. For the most part, it's consistent, but we'll have to make a couple of changes when we're doing the moves over here. So let's start with the number long division problem. I'm going to make a slight change because this is going to do something that I don't want it to do. I'm going to change this first 2 in the dividend to an 8. only because if it were 12, then, well, I'll point it out in a moment. All right, so let's say we're doing this long division problem. What's the first question you ask yourself? You ask yourself, how many times does 12 go into 18? 12 will go into 18 one time. You write a 1 on the top. Over here, we kind of do the same thing, except we got to make some adjustments. Adjustment number 1. When you ask the opening question over here, you don't look at the entire divisor. You only look at its leading term. And the same thing with the dividend, you only look at its leading term. And you ask yourself the same question. The question over here was how many times does 12 go into 18? The question over here is how many times does x go into x to the third power? Now, that might seem like a tricky question to answer. How many times does x go into x to the third power? That's equivalent to asking what is x to the third power divided by x. But every division problem can be written as a fraction. So to figure out what's going to go up top, we can start by asking, well, let me write in words the first question that I asked. How many times does x go into x cubed? But that's equivalent to asking, in other words, that's equivalent to asking what is x cubed divided by x. So one way to think about what goes up here first is to put the leading term of the dividend on top of the leading term of the divisor. In other words, take these two terms and stack them on top of each other, and you should get a fraction that you can reduce easily, especially if you remember the exponent rule that says when you have one power on top of another, you subtract the powers. 3 minus 1 is 2, so x to the third power divided by x is x squared, and we write that up top. So it's the same question. How many times does 12 go into 18? Once. How many times does x go into x cubed? Or equivalently, what is x cubed divided by x? X squared, and that goes on top. All right, so what's the next move over here? You might think it's to subtract, but there's not. There's a move that precedes it. Once you calculate the first digit in the quotient, your next move is to multiply that digit times the divisor and write the product underneath the dividend. So in this case, 1 times 12 is 12. I think everybody remembers that move. The move over here is exactly the same. But when you multiply it, you don't just multiply it by the leading term, you multiply it by the entire divisor. So your second move is to multiply x squared by x minus 2, and this will invoke the distributive property. So x squared times x is x cubed, write it underneath the other x cubed, and then x squared times negative 2 is negative 2x squared. So it's the exact same move as over there. Multiply the first term in the quotient times the divisor and write the product underneath the dividend. It's important to keep your like terms lined up because I think you know what's going to happen next. So what is the next move over in the number division problem? After you multiply 1 times 12 to get 12, you subtract. 18 minus 12 is 6. This is the reason I changed the 12 to an 18. I didn't want this to be a 0 in this first example. So that move is easy, just subtract. And what's the move over here? It's the same thing, but this is where most people will make their mistakes. You're going to subtract this product from these terms in the dividend. But if you just put a minus, you're going to miss it. Because if you just put a minus, you are only subtracting the first term, you are not subtracting the second term. To subtract both of them simultaneously, you could put parentheses around it, like that. But then you have to distribute the negative. So if you know that's going to happen, when it comes time to subtract, go ahead and distribute the negative to each term. So this guy gets a negative, and this guy gets a negative, but when he gets a negative, it changes from minus to plus. And then combine like terms. So your third step is to subtract, or, and I prefer this way because it's more descriptive, change signs and combine. I prefer the verb combine than subtract. Subtract seems to imply that it's going to get smaller, but some of the numbers may get larger, as is about to happen here. What should happen is the leading term should cancel. If these don't cancel, something went wrong, go back and fix it. And then these terms combine to give positive 4x squared. Remember, when you combine like terms, the terms stay like terms. 2 of these plus 2 more of those is 4 of them, but they're all still x squareds. It's like 2 apples plus 2 apples equals 4 apples. All right, so that part's a little tricky. You subtract, but I like to think of it as changing the signs and then combining. The leading term should cancel. So let's go back over here. After we did 18 minus 12, what happens next? We bring down the 5. So guess what happens next over here? We bring down the minus 5x. So the next step is to bring down the next term in the dividend. Just like you would do if it were a number problem. Bring down the 5, bring down the minus 5x. And then you just repeat until it's over. So let's finish this one real quick. 12, we just brought down the 5. 12 goes into 65 5 times, because 5 times 12 is 60. 65 minus 60 is 5, bring down the 2. And then lastly, 12 will go into 52 4 times. 4 times 12 is 48. 52 minus 48 is 4, that's our remainder. We'll talk about what to do with it in a moment. But let's repeat everything over here. Remember, when you start by asking how many times does this go into that, only focus on the leading terms, so x and positive 4x squared. And if the question, how many times does x go into positive 4x squared, intimidates you, don't ask that question. Just put the leading term here on top of the leading term there. In other words, put positive 4x squared over x and reduce it. One of the x's cancel and we're left with positive 4x, which would be the next term in the quotient. You'll know if your decision was right if after multiplying these match. They will. Alright, so the next move is to multiply the next term in the quotient, the positive 4x, times all the terms in the divisor. Take it slowly and carefully. Positive 4x times x is positive 4x squared. Positive 4x times negative 2. Positive times negative is negative. 4 times 2 is 8. X times, well, there's no extra x's, so it's a minus 8x. Then subtract or change signs and combine. So let's change this positive to a negative, and let's change that negative to a positive. And combine. As predicted, these leading terms cancel. If they don't, something went wrong. Go back and fix it. And when we combine negative 5x and positive 8x, we get positive 3x. Bring down the last term in the dividend, plus 2. And do it one more time. Remember, you always focus on the leading terms when you ask how many times does this go into this. How many times does x go into positive 3x? Well, put positive 3x on top of x, the x's cancel and it leaves you a positive 3. So positive 3 is the next term in the quotient. And then multiply times the divisor. So we're doing positive 3 times all of this. Positive 3 times x is positive 3x. These matched, we expected that. Positive 3 times negative 2 is negative 6. And then finally subtract by changing the signs and combining. So the positive 3x becomes negative, the negative 6 becomes positive. The 3x's cancel as expected. And when we combine positive 2 and positive 6, we get positive 8. Notice I'm being very blatant about saying positive instead of just 8. Signs will get you here. Make an extra concerted effort to keep up with them. Okay, so how do we deal with the remainder? Well, let's back over here. Look back over here. There's a few ways to deal with this remainder. I know of 3 ways. Put an R4, we're not going to do that. Put a decimal, some zeros, and keep going. Not an option over there. The way we are going to deal with the remainder is by attaching it to the quotient as the numerator of a fraction. We have 4 out of 12 left. Now, I know 4/12 reduces to 1/3, but let's not worry about that right now. I can append the remainder to the quotient by putting it on top of the divisor. If I put the 4 over the 12, I can tack it on to the quotient. Now, how would we do that over here? Well, the answer is essentially the same way. The only difference is we need to explicitly state if we are adding or subtracting that fraction. Because the remainder is positive, plus 8 over what we divided by. And so the answer to the polynomial division problem is x squared plus 4x plus 3 plus 8 over x minus 2. This is actually straightforward. It just takes a little getting accustomed to. We'll do another one in the next video, and it'll probably go a little bit more smoothly, especially since this video is at the 16-minute mark. I am so sorry.